This is a continuation of March 30th lesson. This will be part 2. We have now done Cartesian equations in 2-space. We're now moving to 3-space. Keep in mind, what happens in 2-space happens in 3-space. The same as before, except we need 2 points, or a point and a position vector. Okay, here we go. I'm given 2 points. Generate a vector and parametric equation. This is stuff we've done before. First of all, I need the slope of this vector. So I will get -2 minus a -2. 4 minus 3, -1 minus 5, which will give me, don't tell me, that to be negative, 0, 1, -6. If you had done it the other way around, you would have had 0, -1, 6, and it doesn't matter. Either one's fine. Okay. I need a point, and I need a direction vector. There's my direction vector right here. So I need a point. So L line is going to be, pick a point, -2, 3, 5, plus a parameter, 0, 1, -6. Or if you wanted to, line 1, line 2 could have been -2, 4, -1, plus t, 0, 1, -6. Either one is fine. These are vector equations. Whichever one you pick is your business. For this one, I would have gotten x equals -2 plus 0t. Y equals 3 plus t. Z equals 5 minus 6t. In all likelihood, we just simply wouldn't write this down. But you could, but if I had used this one, x equals -2, y equals 4, t, z equals -1 minus 6t. These are parametric equations. Easy enough. Equivalent lines can be written in many different ways. Handy to tell if they're equivalent. All right, 3-space, we have these. Are these lines coincident, or are they just parallel, or neither? If you examine the slopes, -1 times 2 is this. So if I multiply this one by 2, I'll get this, and I'll get that, yes. So at minimum, these guys are parallel. But are they coincident? If they are coincident, a point from one should be on the other. So let's take the point 4, -10, -21, and plug it into the first one. Replace the letter R. So I would get 4, -10, -21 should equal -1, 0, 4 plus S, -1, 2, 5. Hopefully I'm copying it down right. So this point here should be able to go there. Break it into parametric. 4 equals -1 plus S. -10 equals 0 plus 2t. 2s. Sorry, S. And then -21 equals 4 plus 5s. S equals 5. -10. Did I do this wrong? Something seems wrong here. Oh, that's a negative s. So that's going to be -5. Equals 2s. S equals -5. Bring that across. -25 divided by 5 equals s. S equals -5. If they're all the same, on the line, these guys are coincident. Like usual, it's the little mistakes. Be careful. Page 1. Okay, I have more pages. Where the hell did I put them? Page 5, I think. Are these lines coincident or parallel? Same strength. It's exactly the same thing. Now, I think that this one here, I made a typo. I think that there was supposed to be a negative there, so make that negative. Sorry about that. If I multiply this guy by -2, that times -2 is -1. That. So yes, these guys are parallel. Great. But are they coincident? I'm going to pick this point and I'm going to put it into here. -3, 10, 12 equals 161 plus k, -1, 1, 2. -3 equals 1 minus k. 10 equals 6 plus k. 12 equals 1 plus 2k. -4 divided by -1 equals k. K equals 4. 4 equals k. So far, so good. 9 divided by 2 equals k. These are not, all three are not the same. Therefore, these are not coincident. These two lines will never touch. Okay. Now, that was a Cartesian. These are parametric and equivalent. Now we're going to this one here. Symmetric equations. Here is a general equation. How much time do we have here? I can't tell. I'll do another sheet. I want you to put this in parametric form. X equals x naught plus AT. Y equals y naught plus BT. Z equals Z naught plus CT. Solve for T. T equals x minus x naught over A. T equals y minus y naught over B. And T equals Z minus Z naught over C. This one equals T, that equals T, that equals T. Therefore, x minus x naught over A equals y minus y naught over B equals Z minus Z naught over C. A, B, and C cannot equal 0. Otherwise, this is a symmetrical equation. Okay. This is another form of a three-dimensional equation. It's going to come in handy. Now what do we got? Page 6. I'll stop here.